Hello everybody and welcome back to Advanced Maths. Today we're looking at integration, areas under curves. So, we've got a curve here, y equals f of x, and we've got lines a and b, and we've got the x-axis at the bottom. These four lines, a, b, the blue curve, and the x-axis, make a green region. And the area of that green region is given by the area equals the integral from a to b of f of x dx. That's the equation on the left for the area on the right. Before we continue, pause the video and make a sketch of this in your book so that you remember it. The area between a and b of f of x dx is given by this integral here. It's between a and b, the x-axis on the bottom, the blue line on top. If you're happy, and if you know integration, we can continue with our first example. If you're not confident with integration, watch my videos on integration before we continue, because you should know how to integrate things really confidently. So, let's look at the example. We've got the graph shows a sketch of y equals 3x squared plus 4x plus 1. What is the area of the shaded region? So we've got the green region here on the right that we want to find. And it is between -1 and 2. The x-axis on the bottom, the blue curve is on the top. And so we're going to integrate that curve between -1 and 2. So it's the integral between -1 and 2 of 3x squared plus 4x plus 2 dx. Okay, so we're going to have to evaluate that integral and watch how I do this. I'm going to integrate 3x squared plus 4x plus 2. 3x squared integrates, we add 1 to the power and divide by the new power. Like this, 3 divided by 3 is 1. So 3x squared integrates to x to the power 3. 4x, we add 1 to the power, at the moment it's 4x to the power 1. We add 1 to the power, is 4x squared. Divide by the new power, 4 divided by 2 is 2. We get 2x squared. 4x differentiates to 2x squared. Now 2 integrates to be 2x, just because it's a number integrates to 2 that number times x. And we get this. There is no plus c on the end because this is a definite integral. A definite integral means that it's got bounds. Between -1 and 2, it's got bounds. So we do not need a plus c in the end. We do not write a plus c when it's got bounds. And so we've got the area is between -1 and 2 of x cubed plus 2x squared plus 2x, like this. And this is a notation we use. Look at the square brackets I'm using and the fact I'm still using -1 and 2 at the start to show that I still need to substitute those in. And what I do is I have the bracket for the 2 and the bracket for the -1, and I subtract them. The top power, the top number goes at the first, the second number goes second, and I subtract them. I substitute 2 in, like this, and I subtract the second bracket. And I evaluate this. So I've replaced all the x's with 2 in the first bracket and all the x's -1 in the second bracket. And when you substitute -1 in, that is a negative number. And you have to be really careful when you're substituting minus numbers, you don't make a mistake. And when you work all this out, when you do all the bib maths with this, I get 20 minus -1, which is 21. And I've figured that out. I've done. You can use your calculator for that, of course. So the area is 21 units squared, and that's the final answer. Okay? Now, let's look at another example here. So it says, consider the graphs y equals -x squared plus 4x plus 8 and y equals -x plus 8. Find the area bounded by the two curves. So we've got y equals -x squared plus 4x plus 8 and y equals -x plus 8. And the area under the first curve is this orange area. The area under the second curve, or straight line, curve, straight line, whatever you prefer, is the blue area here. And the area bounded by the two of them is this green area here. And to find that green area, what we're going to do is going to have the orange area minus the blue area gives us the green area. The big area minus the small area gives you the area between the two curves. Like this. And it's between 0 and 8 and 5 and 3. These are the coordinates where they cross over. If you're not told the coordinates where they cross over, or it's not obvious from the question, you might have to do some simultaneous equations to find where they intersect. Or if you've got a graphing calculator, you can also use a graphing calculator to find the coordinates where they intersect. For this question, we're just going to assume we're given the coordinates already, but in more complicated questions, you might have to figure them out yourself. So the area of this is given by the area of the area under the big curve minus the area under the second curve, which looks like this. So we've got the area of the first one, area of f of x, minus the area of g of x, the other curve. You can subtract them, because as we said before, it's the big area minus the small area is the area between them. Now, a simpler way to do this is just to do it as one integral. So you're allowed to do this. You're allowed to do f of x minus g of x and integrate like that. It's a bit quicker this. And for this, the f of x is going to be the function that goes on top. And here, the orange function is the one that's on top. The blue one, the blue line is the line that's on the bottom in this green region. So we substitute these numbers in, substitute the functions in, and we get this. The integral of minus x squared plus 4x plus 8 minus x plus 8 dx. We can simplify that. Just be careful your minus sign here. Minus is positive, minus plus 8 is minus 8. And it's between 0 and 5 because the x coordinate of the first coordinate is 0 and the second coordinate is 5. Substitute those in and simplify the expression. And it simplifies to be this. So minus x squared plus 4x plus 8 plus x minus 8. The minus 8 and the plus 8 disappear. The 4x and the x combine to be 5x. It simplifies very nicely to be this. So if you, it's far simpler to subtract the two functions first and integrate. We integrate this, and when you integrate minus x squared plus 5x, you get minus 1/3 x cubed plus 5/2 x squared. I'm going to substitute the 5's in, I'm going to substitute the 0's in, and subtract the second bracket where you put the 0's in. And when you type this into your calculator, you get minus 125 over 6 units squared. You're welcome to try it yourself with your calculator. And that is the final answer. If you have got a graphing calculator, what you can do is you can actually just type this into your graphing calculator. The integral between 0 and 5 of minus x squared plus 5x dx. Which is really nice, and I have a short video on that, which I'll link in the description if you're interested. Perfect. And that's how you find the area between two curves. So now we know how to integrate to find areas between curves. If you found this useful, please like and subscribe and share this video with your classmates and friends. Every little helps. Thanks for watching, good luck in your exams, and see you in the next video.